have what's called a common ratio. Between each term is multiplied by the same factor each time. Multiplying by 2, multiplying by 6, multiplying by 1/3, or something along those lines. It's constant. It's a very easy thing to come up with. How you come up with whether or not something is geometric is the same thing every time. For example, if I look at the first sequence here of 1, 2, 6, 24, and 120, and I want to decide whether or not it is geometric, I have to see if, to get to the next term, if it's being multiplied by the same value each time. Here's how you check that. You always start with the second term, and you divide it by the first term. Does that equal third term divided by second? Does that equal fourth term divided by third? Does that equal fifth term divided by fourth? And so on and so forth. You're checking to see if each one of those has the same ratio. So, is 2 over 1 the same as 6 over 2?
No.
So is that geometric?
Nope.
No. You need to go to the next problem.
What is it then?
I don't know. Nothing. It's a
Oh,
sequence.
you said, like, it's not geometric.
It's just not geometric. Okay? You could probably figure out the pattern and continue on like you did in the very first section of this chapter. But in this case here, if I'm talking about whether or not it's geometric, I'm done. I go to the next part. Okay? Yep. You always start with the second one divided by the first. It's the easiest way to come up with the correct fraction. Yep. Same thing with the next one. I start with 27 over 81. Does that equal 9 over 27? Does that equal 3 over 9? Does that equal 1 over 3?
Yes.
It does. That would be considered a geometric sequence. And what is the common rate? 1/3. I don't want to say 3. I'm saying I want to say the rate is 1/3. Okay. If it was 3, it would go 81, 243, and so on. It would be getting larger. See what I'm saying? See, does that make sense? Okay. By doing this division like that, it will allow you to come up with the correct fraction. All right. Instead of, because I don't like to say that the rate is being divided. I always like to say it's being multiplied. All right. It's the common multiplier, multiplying by 1/3 and so on. Okay. Which means now we know that something's geometric, we're going to write the rule for the nth term. And in order to write the rule for the nth term in a geometric, we'll use the same exact example. We use the first term. Well, I'll just start with it. The whole kit caboodle is the nth rule for geometric is first term times the rate, that r, to the n minus 1. Now, in our quick example we just did there, what was the first term? 81. I know my first term is 81. What was the rate? We already figured that out. 1/3. The ratio, yeah, the ratio. Okay? It's 1/3. All I have to do is put it together now. I know that my nth rule is my first term. Little, I don't know, nomenclature, if you will. Put your ratio or your rate in parentheses. It's just a cleaner way of writing it. And you're done. That's your rule. You can't combine like terms. You're not simplifying. You're not doing anything else. You're right, because the rate has the exponent. Okay? And that's how that works. Okay? It's a little bit cleaner than doing all with the differences. You don't have to combine like terms. You don't have to worry about your signs. It's pretty straightforward with this.
The only thing we have to do is find the rate.
Correct. Okay? So let me show you an example. We're going to write the rule for the nth term, and then we're going to figure out what the 8th term is using that rule. So we have a sequence. Our sequence is -8, -12, -18, and -27. If I want to go ahead and start, I want to always write out my rule. My nth rule here is going to be first term r to the n minus 1. What's your first term? The first term is negative 8. Our rate here. Do I have to go through and check all the ratios?
No.
I don't, and why is that?
Because you know it's geometric.
Because I know it's geometric. So all I have to do is take the second term divided by the first. And in the TI-84s, do you guys know how to simplify fractions? Yeah, if you just put it right into the fraction bar, if you remember the fraction bar for these guys is alpha y equals. If you type it directly into there as alpha y equals, and then go negative 12 over negative 8 and hit enter, it will simplify it for you. Okay? It'll do the work for you. Especially if you forgot how to do it. Okay? So my rate in this case is how much? 3/2. So now I can write my generic nth rule. I know that my nth rule, first term, r, n minus 1, negative 8. Remember, throw parentheses around your rate to the n minus 1. Pretty straightforward, right?
Yep.
Second part, it asks you to find what's the 8th term. What do I put in for n? 8. All I have to do is substitute in 8 for n now. So the 8th term is going to equal negative 8, parentheses. And again, I can type that exactly the way it looks into my computer, calculator, whatever it's called. Same thing. Do I need to type in 8 minus 1, or could we probably simplify that? It's tough. In the calculator, negative 8, parentheses. Okay. I'm going to be lazy sometimes when it comes to fractions that are very easy to get decimal equivalent because it's quicker to type. Is that okay?
Yeah.
If I write 1.5?
Yeah.
You remember how to do that? Math, enter, enter. And there's your answer.
So you just do one hit carrots instead of.
Yep.
So do you want us to put it in fraction?
I would prefer fraction form for your answers. I believe the back of the book gives you fraction form for answers. For what? How did I get the fraction?
Yeah.
When I got decimal, I hit math, enter, enter, and it comes out fraction.
Fraction into I.
They needed something wrong. I don't know. Not bad, is it? Okay. All right. We're doing okay. Well, just like we did yesterday, or the day before, we had parts where you were given specific term equals something, specific term equals something else. You didn't know what that first term was. Kind of have to do that here as well. Like this. If you're given two terms of the sequence, you're given two parts of the sequence, and you want to write out the rule. What did we do yesterday, or 2 days ago, when we were given two parts to the arithmetic? We did systems of equations, right? How many times did we write out the generic rule? What do you think I'm going to do here? Write it down twice. It's convenient how I set you guys up to do the same thing a little bit, isn't it?
That's really nice.
There's sometimes I kind of might have an idea.
You know.
Sometimes. Once again, the reason that I'm doing this is because I have 2 bits of information, which is going to allow me to get 2 different equations. And you're going to see a little trick here very fast. All right? We know that the second term is 45. Therefore, what is n in this part? 2. Are we okay with that?
Yep.
It says the second term is 45, so n is 2. I know nothing else. So I fill it in. Because it's a sub 2?
Oh.
Yeah. Okay. Now, at this part, is there anything that I can simplify? What's 2 minus 1? Good. I'm going to rewrite this as 45 is the first term times the rate. Is that okay? Yes. Who what?
Where one? How?
What's 2 minus 1?
1.
So it's 45. Okay. So I'm going to do the exact same scenario with the other one. All right? Fill in all the same other stuff. I know that the fifth term is negative 12, 15. So that means n is what? 5. So I fill it in. Negative 12, 15 is first term, r to the 5 minus 1. Otherwise known as 4. Right here. If you weren't writing your other stuff, you probably would have seen that. Do we have two equations that kind of look alike?
Yes.
Okay. Now here's the trick that you might not remember. Distance equals what times what?
Square root of.
Just distance, rate times time,
Oh,
right?
yeah.
Sorry, I didn't mean to scare you on that.
Okay. Oh my God.
This is what we call working with a literal equation. If I wanted to get r by itself, what would I do? Divide by t. So distance divided by time is the rate. Do you agree?
Yeah.
Same thing if I wanted to solve for time, what would I do? So distance divided by rate is also the time. What you're doing here is you've got 3 parts and you're solving for one of them. You've done this before. You have. Okay? Now, the reason why I'm showing, what's that?
Thinking, for instance.
Probably. The reason why I'm showing you that is, could I, since I can't use elimination as a systems of equations here, can I use substitution? Can I get the first term by itself on this side? Divided by r. So if I take 45 and divide it by r, isn't that my first term? So that means anywhere I see the first term here, what can I put in for it? What can I substitute in? 45 over r. 45 over r. I'm using substitution to do this. Here's the other weird part that you might have forgotten. How do you simplify exponents?
Divide, right? One's above, one's below, you divide, right?
Slow your brain down. What were you saying?
One's above, one's below, you divide them, right?
Not divide. Subtract.
Oh, yeah.
What is r? Let me ask you this real fast. R to the 4th means what?
R 4 times.
Do you agree?
Yes.
Okay. If it's r to the 4th divided by r, what simplifies out?
R times R times R.
One set of r's, right? Because what's r divided by r? So it becomes r to the what power? Third. This is working with exponents. If it's r to the 5th over r squared, what do you get? R to the 3rd. If it's r to the 22nd over r, you get? So now, by simplifying this out, I get the following 2-step equation. That's not square root. I'll show you in a second because you haven't seen it on this calculator. To get the r by itself, what do you have to do first? So I'm going to divide by 45, right?
Yep.
All right, so divide it by 45, you get negative 27.
Oh, that's really convenient.
It is, isn't it?
Are all the problems like that?
The ones you guys are going to get, your R value, when you're solving out for R, you should get like a fraction or something that's not going to be god awful. It should be a perfect cube, a perfect fourth root, fifth root, whatever it might be. But here we have to know how to use our calculator to take that, what's called a cube root. To undo the third power, you have a root with an index of 3. It's called cube root. Okay? In your calculator, you hit math. Number 4 is the cube root. You guys see that?
Wait, that's negative.
And I type in negative 27. And an odd number with a negative is an okay thing to have. It works out fine. So my rate here is how much? 3. Negative 3. Now, let me ask you this, because this is going to come up. I want to show you really, while we're on the cube root, R roots and stuff like that real fast, I want to show you how you do this. Fourth root. You'll have to do it. You might have to do a fifth root, seventh root, something like that. If you go back into your calculator real fast, and you hit math again, see option number 5 has an X. Choose that one, and you just have to backtrack and just overwrite it. So let's say you want to take the fourth root of 256. Okay. You will have to do that in the homework. I know that for a fact. Just so you might have to change stuff around. You have to change your index on that. That's how you do it. Now we're almost done with this problem. Oops.
Oh, what are those?
We're almost done with this problem. We know what our rate is, but we still don't have our first term, but we know that the first term is equal to divided by the rate. Convenient, isn't it? Excellent. So your first term is negative 15. Now you know your first term, and now you know your rate, and you write out the end. Cool. Yeah, it's kind of what it is. It seems more complicated than it needs to be. But I try to set this up in a manner that no matter what style problem you guys are going to get, this is always going to work. It's always going to work. Okay? Take one of the equations, whichever one has, whatever you wind up with here. When you get down to this part, see how we had first term r to the first power? Here we had bless you, this one we had first term r to the fourth power. Whichever one of those two equations works out to have the smaller of the two exponents, use that one as your pivot, if you will, to substitute in. It's an easier method. All right? There's a little other twist here that we won't get to, and then the other classes did have another example. Obviously, because the sky was falling, we did not. So if you wanted to see another example, please feel free to throw and look at the other two videos. They did the same example. I just did one more of these. Okay? Yes, sir.
What's their period class number?
3rd and 6th, 7th. It's right. It's listed right on the website.
Okay.
You'll see class. It's right here where it's on the side. It says class 3 video, class 6 video.
Okay.
So it's right there. Okay. Let me give you a couple of these to try. It's still section 11.3. It's on page 670, numbers 39 through 53 odds. I'm giving you the odds in this case so that way you can check your work again. All right.
Homework? Got it? Yeah.
We still have to do sums, and we still have to worry about some of the word problems with these, but you'll find out sums with the ratios really aren't that bad. Well, okay, never mind. I can teach you something else. Okay? Work through those, and we'll continue on it on Monday. Yes, ma'am. Yeah, help yourself. Go ahead and just, flex passes are back there now in that little cabinet. Make sure you sign out with whatever number you're taking and all that kind of fun stuff, okay? All right.
The security, on the still is